Welcome to Lesson 2, Example 10, and it is asking us to draw the moment diagram and calculate the change in moment between points 1 and point 2. There we go, point 1, point 2, they're 3 feet apart. Let's go ahead and just get right into this. So you have your moment is a function of x, of course. And as we've done before, we want to go ahead, it's going to do what? It's going to go up to a point right here. Remember, this is flat, so this slope is going to be a positive 3000x. Is this slope, we know. So let's go ahead and write that equation. It starts at 0, so you could say 0 plus 3000x. 3000x is that slope. Let's say slope. And let's figure out what this point is. To tell you the truth, it really doesn't matter, because what you're going to do is 3000 times the change in x is all that matters, because you're only looking for the change in x. So essentially, let's drop this down. Drop it down. It's going to be about right there. Drop this down, and it's going to be about right there. And the number one, so you're looking for the change in x, which is, and this is, I usually just do delta x, meaning the change in x. And I guess that goes back to thermodynamics, the change in x, the change in temperature, or change in temperature, we do it now. In bridge design, you do change in temperature is delta x, or delta t. Anyways, moving on, not important. We're only looking for that change. So you can assume that we can start at 0, and we're just going over. We're going over 3 feet. What's the change right here after that 3 feet? So you just do 3000 times 3 feet equals 9,000 foot-pounds. And it's simple. It's actually that simple. And you can go ahead and work through the way they did it, but this is the way I would have done it. And this is one of those calculus things where if you know that this, which you do, this is straight over, you're going to know that this is a linear slope sloping up positive 3,000 pounds. So all you need to know is the change, and you can figure that out just by writing an equation and say, okay, well, I'm at this point, I want to get to this point. We know the slope equals 3000x, or 3000 times x. I hope that makes sense. 3000x is your slope. Or what you can go ahead and do, if that doesn't make 100% sense to you, you can go ahead and figure out what this point is. Say, okay, well, I'm just going to do the area A1, which is right there, and say I'm going to go 3,000 pounds times 7.5 foot equals 2,000, or 22,500 foot-pounds. And of course this right here will go back down to 0. We know that. We don't need to calculate it at this point because we're not concerned about anything going on over here. And so you're at, okay, well, let's do a rise over run. And remember the slope, and hopefully you remember this from way back in the day, equals rise over run. And it's always going to do that. Not run. Not run, but run. Alright. And our rise is we're going up 22,500 foot-pounds. And we're running, what, 7.5 foot. Now let's say, go ahead and put the, so your slope equals 22,500 divided by 7.5, and it should equal 3,000, and it does. That's going to be your slope, and that's 3,000 pounds. Since we're getting rid of foot, we're getting rid of foot. 3,000 pounds. And that's what we said our slope was earlier, because that is what over here. Now if you go over here, I want you to think real quick, what is the slope going down? And if you've been paying attention and understand it completely, you'll see that, oh, well, since we did it up here and we said the slope going up is positive 3,000 pounds, well, you should say, well, the slope down here, or down here coming down, is going to be negative 4,500 pounds times x. Hopefully you don't, the slope is actually 4,500, but I like to think it is the equation is 4,500x, and that's x is starting right here. Alright, hopefully that makes sense. We'll go ahead and move on to the next video.